Hi, I'm Leah, and this is Coding at Home. We've been making our way through the skills you need to begin exploring the incredible world of coding. You can use these skills as a starting point for any coding project that you can imagine. Our focus has been to create a digital solution to help Queenslanders know more about cybersecurity. This will also help you develop your very own entry for the 2020 Premier's Coding Challenge. Last week, we started to code using blocks. We talked about collecting user input and storing it in variables to make our program a little bit more interactive. We also had a brief look at Scratch and wrote a simple program. And today, we will develop our program even more by using repetition and branching. We use repetition as part of the things we do each and every day. When we brush our hair, when we wash our hands, when we flip through the pages of a book, we are using repetition. And sometimes this repetition can be continuous. For example, traffic lights. They have to run all the time, even in the middle of the night. The music you hear in the shopping centres doesn't stop after 1 or 2 songs, it plays throughout the whole entire day. So let's take a look at how this works in Scratch. I'm going to program a robot to do a little dance. I want it to shimmy one way and then shimmy back the other way, but I don't want the robot to just dance once. I want the robot to dance all day. In Scratch, we can use what is called a forever loop. This wraps around the instruction and tells our character to follow those instructions over and over. Now, I want my sprite to move forward 10 steps and then wait for 1 second. And then move back 10 steps and wait for a second again. I know it's a pretty quick dance, but we can make this dance repeat by putting it inside a forever loop. However, sometimes we don't want to repeat instructions forever. It would be exhausting dancing all day long. Sometimes we just want to do something a certain number of times. Let's look at an example. Say I wanted to program a building robot to build a brick wall. My algorithm might look a little something like this. Place a brick, move right. Place a brick, move right. Place a brick, move right, place a brick, move right. And so on, until I have placed 10 bricks in a row. Or I could just code my robot using repetition. Repeat 10 times. Place a brick, move right. This is much more efficient because the code now takes up much less space. We can also change the amount of repetitions by changing the code, which is now just in one space. This code can be used to lay as many bricks as we want. The repeat block in Scratch runs all of the blocks inside it from top to bottom. The number of repetitions is controlled by the number that comes after the word repeat. Let's take a look at how we could use Scratch to program our robot to lay some bricks. The other concept we'll look at is branching. You were introduced to branching back in episode 3, where you looked at what happened to the program when you started asking questions. Do you need to brush your teeth? Do you need to get dressed? There are a few ways that block coding uses branching, but the most common is with the if statement. There are 2 parts to the if statement, the condition and the action. Here's how we do it in Scratch. The small input at the top of the block between the if and then is called the condition. The large gap within the block is the space we need to place some actions. If a particular condition happens, then do an action. Let's look at some specific examples of how branching works in Scratch so you guys get a better idea of how this works. Using an if-then block, we can set it up to run as follows. If a key is pressed, then say hooray. This part is the condition, and this part is the action. Let's look at another example that could be used for a chatbot. As our user is providing us with some input, we might want to check to see if the answer is what we expect. Because we ask the user for some information, some user input, we want to start with the ask block. The answer to that question is then stored in the answer block. We then use the if-then block, the block we used before, but this time we change the condition to take into account the user input. If the answer, that is our user input, is equal to Leah, then we get our character to say, "Hi Leah." Now this is pretty good, but it would be even better if our chatbot could say hi to any user, not just me. We can use a more advanced version of the if-then block called the if-then-else block. You can see that this block has space for two separate actions. The else part of this block allows our program to run another action if the condition wasn't what we expected. To recap, today we made our chatbots a little bit smarter by introducing some new programming concepts. Firstly, repetition. When we want to do a series of instructions over and over again, it makes sense to have a specific repeat command, rather than explaining each step over and over. If you notice similar steps appearing in your code, you might need to consider a repeat block. And branching. Sometimes there are decisions that need to be made in a program, and the instructions that follow are dependent on the results of those decisions. Up next, you'll get some tips on how to add questions and answers to a chatbot, and we'll meet some industry experts who are giving us a glimpse into the incredible future of coding. You're watching Coding at Home, and if you're anything like me, you're probably totally hooked on coding right now. Once you've explored coding and mastered some of the basics, the future is full of possibilities when it comes to what you can create. If you see plenty of coding in your future, then you're not alone. Let's catch up with some experts who see coding in all of our futures.
It's so dark in here. Where are the light switches in this place? If only I was living in the future and I could just tell the lights to turn on.
You are in the future, Stace. Just listen to it. Hey lights, turn on.
That's amazing. How did that just happen?
There are microphones around this room, and there are algorithms that listen to whatever I say. The technology is called voice recognition.
So you're telling me the future is now?
It just started.
Here to shine a light on this emerging and amazing technology is Professor Marek Kowalkiewicz from QUT.
Marek, tell me more about this amazing technology.
Sure, Stace. So look, this is already happening. Some of your neighbors, maybe someone in your family might already have a smart home or a smart car or a smart fridge.
That will certainly help save time, but how will it work?
For instance, when you have a smart fridge, some of them can already now detect that you're running out of milk. Perhaps you've removed an empty bottle of milk. What the fridge will do is it will automatically reorder it for you, so next time you don't have to worry about it. With a smart car, some of your neighbors, maybe someone in your family might have a car which has an autopilot mode. What it means is when you press this magic button, you can effectively just take off the hands of the wheel and the car will drive itself.
Now, it obviously helps us in our personal lives at home. What about in business?
It's actually very similar when you think about it. Those smart technologies are basically trying to understand the needs of those who use them and then are providing all sorts of services that meet those needs. So when at work, you can hire algorithms to help you be more productive. I have an Amy and an Andrew in my office. They are algorithms. They read emails from students And whenever students ask me for an appointment, they respond to those emails and set up that appointment. Now, the best part about it is sometimes students don't even realize that they're chatting with a robot. They think it's a real Amy or a real Andrew. But when you're a doctor, you might have an algorithm that helps you analyze the health results of a patient. When you're a car mechanic, you might have an algorithm that helps you understand the behavior of the engine inside the car, and so on and so on. They basically help us be better employees, but also be better employers.
So all of this exists now. What do you think the future will look like?
The future is very exciting. Those algorithms will be even smarter. They'll be able to predict our needs. They'll be able to be very proactive. Sometimes they will understand that we need something even before we do. But a smart fridge of the future might actually be able to connect to your calendar and understand that there's a party coming up. It might be able to look at the profiles of people who are attending your party. And if it sees there's a few vegetarians, for instance, it will make sure that it orders food that they will enjoy.
Artificial intelligence isn't just helping people prepare for parties and turn the lights on. Alex Ma is also benefiting from AI every day in his job at BHP.
BHP is a natural resources company. We mine iron ore, coal and copper. My role as the manager of technology is we improve operational tech and we work our data harder to optimize the operations.
Wow, I bet there's some exciting technology out there helping you on a day-to-day basis.
Yeah, I love my job because we're leading the push into the digital age. We call this Industry 4.0. What it means is on the ground we have more tablets and wearables, allowing our crews to diagnose and analyze situations on the run. It also allows, for example, our process engineers to fine-tune our equipment simultaneously. This helps our operations run faster, safer, and more productive. We also use drones to provide a visual of hard to get to or expensive to get to places. It also helps us keep our employees out of harm's way.
Now, we've been learning a lot about coding languages and how algorithms work. Is that something that helps you in your day-to-day job?
Yeah, it is, absolutely. We use Python in our work to do machine learning and analysis. So there's tasks that could take two weeks to do, but now it takes data crunching maybe a couple of hours.
That sounds like a real time saver. How else is AI helping you be more efficient?
It is. At work, my role is to provide advice. I created a chatbot that helps my colleagues get information more precisely and quicker. You can even use it on the smartphone, so during a meeting we can get information immediately. And that's what the crux of artificial intelligence is. It's designed by humans for the benefit of humans.
Now the future, or should I say the present, sounds very exciting. What would your advice be to someone who's interested in going down that career path?
My advice to people looking for a similar career pathway or getting ready for the digital age is to improve your digital literacy skills, your collaborative thinking, your creativity, and your critical thinking. The good thing about coding, it's all about trial and error and improving your mindset. Just don't crash the computer.
Alex and Marek sure did have some inspiring thoughts on what the future holds. Isn't it amazing that some of this technology already exists today?
Coming up, we'll get smarter by learning how to make our chatbot ask cybersecurity questions and give us answers. I think we've got a pretty good grasp of the basics, but if we're going to create a chatbot to teach Queenslanders more about cybersecurity, it's going to need to do a lot more than just say hi. Our chatbot needs to level up, and so do the coders. Thankfully, our next guest has the skills to help us all out.
Hi, I'm Nat Anderson and I'm a teacher at Pacific Pines Primary School. I teach Year 5 and 6 and I also help teachers to teach STEM, in particular technology. Today I'm going to show you how to add questions and answers to your chatbot and how to use repetition to make it even smarter. Last week, Damien introduced you to coding a chatbot. Chatbots are robots or programs that automatically respond to things that you type. They can be used for learning information or just to talk to them like other humans. Their code searches for specific words and phrases in what you type, and then chooses an appropriate response in return. Damien showed you how to start your chatbot talking by asking the user their name and then using that name in a reply. Earlier in this episode, Leah showed you how to use a repeat block and the if, then, else block. Today we're going to use everything that we've learned so far to keep building on our chatbot code. We're also going to teach our users about cybersecurity. First, I'm going to write some blocks of code to greet our user. I've decided to call my chatbot Cody. Cody starts with an introduction and then tells the user what to expect. I'm going to do this by going to the looks blocks and dragging over say hello for 2 seconds. I can then click into where it says hello and type in, "Hi, I'm Cody and I'm here to teach you about cyber security." The next coding block will ask for the user's name and then store the user input in the answer variable. I'm going to do that by heading to the sensing blocks and dragging over the ask what's your name and wait block. Then I want to use a join block to join hi and the user's name. To do that, I'm going to head back to my looks block and drag over say hello for 2 seconds. This time I'm going to need a join block. You'll find that in the green operations blocks, and it says join apple banana. So if you drag that one up and drop it in where it says hello, you can change apple to hi. And for banana, we want to drag in the answer. So back to the sensing blocks and drag over our answer block. Let's test our code by clicking on the stack of code blocks. Great, it works. It's always a good idea to test your code and evaluate your progress as you go. Now would be a good time to use a branching statement so that Cody can welcome me back or say hi to a new user. I can do this by using an if, then, else block. I want to keep the say hi answer block to use later. So for now, I'm going to drag that block to the side. After the ask block, I'm going to insert my if-else block. You can find this in the orange control blocks. I will then need to go to the green operators blocks to find the operations block that I need. This will first appear as a blank circle equals 50, but I can change those blocks. We'll get to that soon. First, I will drag the green operations block into the condition space between if and then. I need to drag the blue answer variable from the sensing blocks into the blank circle in my operations block and then type nat where the 50 is. So that if the condition is true, then the action will happen. I want to say that if the answer is nat, then the chatbot will say, "Welcome back, Nat." I then drag my block from earlier into the else section of my branching statement. This action only runs if the answer is not equal to nat, in which case my chatbot will respond by saying hi, joined to the user's name. Now we're ready to add some cybersecurity content. From our research, we know that our passwords are for us and not to be shared with others. Our parent or guardian might need to know our password, but we should definitely not share it with our friends or people we don't know. Let's ask a true or false style question. We also need to tell the user how we want them to respond. In this case, we want the user input to be A for true or B for false. The correct option to answer this question is B. So in our if-then statement, I will use a green operations block to set the condition to if the answer is B, then let the user know that they got the answer correct and give them some more information on the topic. This is looking really good. Now, it would be cool if we could make this more interactive by giving feedback to the user if they select the incorrect answer. In this case, that's option A. So if they select A, we can tell them that this answer is incorrect and give them the real answer. Because we need another action, we'll change to an if-then-else block. The incorrect answer, will go in the else action space. Our code now asks, it's okay to share your passwords with a really good friend from school. Type A if it's true or B if it's false. If the answer equals B, then say, great job, it's never okay to share passwords with a friend. Else, say, this is not a good idea. It's never okay to share passwords with a friend. This program is getting really close to where I want it to be. However, I think we can make our code even better. Right now, our program only runs once. This is okay, but it would be better to run our program continuously so that we can teach anyone about cybersecurity. This sounds like a job for a forever loop, so that our program never ends. I'll drag out a forever loop and place all of my code inside it. Then I'll use a flag block to activate my code stack. Now it will run forever. This is an amazing program for our second time using Scratch. Let's reflect on what we've done and evaluate our work. Our program has an informative greeting, but it only has one question. Our loop works well, but what happens if my user accidentally presses something other than A or B when they respond to the question? Being able to consider how our program can be improved is so important. Remember that a great design process requires lots of evaluation and improvement so that each version is better than the last. A great way to improve is by seeking feedback from your users. Get a friend to test it out. Ask them what they like about your project and also what you can make even better. Okay, let's recap what we've learned. Today we used if-then and if-then-else blocks to ask our user a question. Then we used a repeat block to keep our code running constantly. Right now, our code only has the one question. To create more, we can use the duplicate command to create another question. This is a handy trick for lots of code. If I right-click on my ask, I get the option to duplicate. All I need to do then is connect this new stack of blocks to the bottom of my existing blocks and edit the questions being asked. Don't forget to change the answers too. Start thinking about other areas of cybersecurity. What questions need to be asked and what is important for your users to learn? Can you build on your code and add a celebration when your users get the answers right? Or maybe even keep a tally of their score. I can't wait to see what you come up with. Happy coding!
And with that, we have just about everything we need for our coding project. If you still need some help getting started, then remember the 5 steps we outlined in our first episode. Decide on your audience and design a solution that will appeal to what they like. Research cybersecurity or the topic your chatbot will cover. Design your chatbot algorithm. Use a flowchart to assist. Write your code. Use a program like Scratch. Test your chatbot and evaluate how well you did. Does your digital solution solve the problem? We'll be back next episode with some final tips and advice for presenting and evaluating your project. We'll catch you guys next time. Bye!
Authorised by the Queensland Government, Brisbane.